Good morning, chemistry students. My name is Mr. Ed. This is chemistry. Today is the 24th of April. It is a Friday, and it is a day 2 in our rotation. Happy Friday, everybody. Hope you had a good week. Hope you managed to get through everything in chemistry okay this week. We went through our last lesson in Section 1. We had a review on Section 1, and then we had our quiz on Wednesday, and now we're starting Unit 2, Section 2. So the results for the quiz should all be in now. Again, if you got a 15 out of 25, 60% or above on that quiz, you got a pass, no questions asked, you're good to go. If you were one of the people who didn't quite manage to accomplish that, or if you didn't even take it yet, I will be sending out a plan to make that up at some point, another makeup quiz per se, so that you can pass that and move on and make sure you hit that standard, achieve that objective. So today, it's Friday. Happy Friday, everybody. We're going to do our usual video meetings, live video meetings on Friday like we've been doing. So again, that'll be 1:30 for second period, 2 o'clock for third period, 2:30 for fifth period, and 3 o'clock for eighth period. So we'll be on Google Meet again, just hanging out, saying hi. We got about like 4 or 5 people per period last week, which was pretty good. But make sure you stop by and say hi at those meetings if you have a chance to do that today. So today, we're continuing on with our beginning to Unit 2, Section 2. And yesterday I told you all that this section is all about 3D molecules, right? Molecules in three-dimensional space, what shape they make, how they take up space, what kind of shapes atoms will actually form in real life, because those shapes affect how molecules will interact with the body or interact when you smell them or interact with each other, right? That's going to be a really important concept for biology when you take that next year. So it's important to know a little bit about how molecules form and what their shapes look like and all that, okay? So we said we were talking about the 3D nature of molecules yesterday, and we said we were looking at these things that we call ball and stick models. Now, in your assignment today, you're going to have 3 different molecules, and in your readings in the books, you have those same 3 molecules. You have what's called geraniol, menthol, and phenol, right? And those, because they all end in OL, and because they all have one oxygen in them, and they all have that OH functional group, right? If you see this here, this OH functional group, means that they're all alcohols, right? So these are all alcohols that end in OL, have one O, and have that OH group. So they're all alcohols, and therefore we would expect them to smell quote-unquote medicinal, like we learned in that lab lesson that we did. But what we're going to find out is that maybe there's something more than just functional group, which determines smell, right? So we're going to look at these molecules a little bit in the assignment today and say, okay, why do they smell different? I'm telling you they smell different, but why do they smell different? So our first molecule is geraniol. And the smell for that says that it is, I think it is like flowery or sweet. I don't remember how it's categorized exactly. But I believe it's flowery. Yeah, we're going to go with flowery, okay? So this one smells flowery or sweet, right? So this is geraniol, okay? If you look at this molecule, you notice immediately this red atom connected to an H atom, and that is your alcohol, your OH group. But look at geraniol for a second. Look at what's special about it. What do the carbons look like? Kind of all in a line, right? There's nothing super special about them. They're all in a line in a chain, okay? So our second molecule is menthol, okay? So this is menthol, right? Again, if I flip it the right way, again, you can see that there is an OH group. So again, it is an alcohol. But menthol smells kind of minty, right? It has that kind of, what's the scent? Menthol is the one that, if you have a mint in your mouth, it makes it feel cool, right? It has that cooling effect. So menthol, what's special about this, right? It has that OH group again, so an oxygen and a hydrogen. So it's an alcohol. But are the carbons all in one long chain? They're not all in one long chain, right? They're in this kind of ring. If you see right here, there are 1, 2, 3, 4, 5, 6 carbons all in a ring here, okay? So having that ring structure and that OH group together makes kind of that minty smell. So you're looking at kind of the 3D nature of molecules here. You're looking for what the carbons are arranged like, or what kind of pattern are they in? Are they in a straight line? Are they in a ring or something else, right? Okay. And our last molecule down there is phenol. And phenol smells kind of piney, right? So again, we have an alcohol where we have an OH group, so a red oxygen and a white hydrogen attached to it. But what's different about this molecule from the rest? I'll try to get it at the right angle. There you go. Okay. So you have the OH, but how are my carbons arranged, right? It's hard to touch the right parts of the molecule I want to touch. They're in this ring of 1, 2, 3, 4, 5, 6 carbons again. But if you look at the back, right through here, you should be able to kind of see, right, that there is a carbon molecule through the back there. So there's a carbon molecule kind of in the back or in the center of those, right? You can see it right here. This is that carbon molecule is in the center. You can see my ring, 1, 2, 3, 4, 5, 6, and then that carbon in the center. So when you're looking today at those structural formulas and those ball and stick models of Fencol, you want to notice that there is a carbon ring with 1 carbon in the center. And again, if you look at your book, if you look at those structural formulas, you can kind of see those carbons arranging in that pattern. You can kind of see the carbons either all in a chain in the case of geranio, or in a ring in the case of menthol, or in a ring with the carbon in the center in the case of Fencol. So you want to look at those different patterns and realize that the shape of the molecule, how those carbons are arranged, is absolutely going to contribute to the smell and why it might smell a certain way. So that's all I really have to tell you today. So get that assignment done, and then you are done for the week. Unless, of course, you'd like to show up for meetings today, which, like I said, I'll send out a link for. I'll send out a Google Meet for those, as always. I look forward to seeing any and all of you at those meetings. They're always a good time. We usually don't talk about anything too sciencey or serious, but we just kind of chat and see how things are going. So I hope to see you there today. Happy Friday, everybody. I hope you enjoy your weekend, and I will see you all either today or on Monday. Let's go 1, 2, 3. Clap on me.